Welcome to the mathematics in my channel. Today we are going to solve another interesting integrals. Integral from 0 to pi over 4 natural log of sine of x dx. Integral from 0 to pi over 4 natural log of cosine of x dx. How to begin? Okay, first I am going to take this integral is equal to I and this integral is equal to j. Now I am going to take I plus j. So we can write I plus j 0 to pi over 4 natural log of sine of x dx plus 0 to pi over 4 natural log of cosine of x dx. Okay, then integral from 0 to pi over 4, we know natural log of sine of x plus natural log of cosine of x. Now property of according to property of natural log, we can write this is equal to natural log of sine of x times cosine of x dx. Okay, then we know sine of 2x, double angle formula, sine of 2x is equal to 2 times sine of x cosine of x, and now we can isolate the sine of x cosine of x. So we can write now this is equal to 0 to pi over 4 natural log of sine of 2x over 2 dx. Okay, now again according to property of natural log, we can write this is equal to 0 to pi over 4 natural log of sine of 2x dx minus this division we can write as minus sign. So here 0 to pi over 4 natural log of 2 dx. Okay, now to evaluate first integral, I am going to take a substitution to this integral. So I am going to take 2x sorry 2x is equal to u, then 2 dx is equal to du. Okay, now we know lower limit when x approaches to 0, u also approaches to 0. Upper limit when x approaches to pi over 4, we know u approaches to pi over 2. Here natural log of sine of now 2x is equal to u, so natural log of sine of u. Now dx is equal to du over 2. So 1 over 2 is a constant, so we can write outside of the integral sign, and here natural log of 2 also a constant, so we can write outside of the integral sign, and here we have 0 to pi over 4 dx. We know x limit 0 to pi over 4. Okay, now here I plus j, so I plus j is equal to now here 1/2, and this is very famous integral. We know we evaluated this integral before. 0 to pi over 2 natural log of sine of u, we know minus pi over 2 natural log of 2, and here natural log of 2 x limit 0 to pi over 4, so pi over 4. Okay, then we know I plus j is equal to sorry, here minus pi over 4 natural log of 2, here minus pi over 4 natural log of 2. So we know this is equal to minus pi over 2 natural log of 2. Okay, I am going to take this equation is number 1. Okay, then now we evaluated I plus j. Then I am going to take I minus j. So if we take I minus j, we can write 0 to pi over 4 natural log of sine of x dx minus 0 to pi over 4 natural log of cosine of x dx. Okay, then we can write this is equal to 0 to pi over 4. Now according to property of natural log, we can write this is equal to natural log of sine of x over cosine of x dx. Then we know sine of x over cosine of x is equal to tan of x dx. Okay, now to evaluate this integral, I'm going to take a substitution. So if we take u is equal to tan of x, then we know x is equal to arctan of u. Now differentiate, dx is equal to 1 over 1 plus u square du. Okay, now we can plug in here. So now we know limit when x approaches to 0, u approaches to also 0. When x approaches to pi over 4, we know u approaches to 1. And here natural log of tan of x, we know u, and dx is equal to 1 over 1 plus u square du. Okay, now instead of 1 plus u square, we can write the infinite series. So I'm going to take now integral from 0 to 1. Here natural log of u. Now instead of 1 plus u square, I'm going to write infinite sum. N is equal 0 to infinity minus 1 to the n u to the 2n du. Okay, then this sigma notation we can write outside of the integral sign. So sum of 0 to infinity, here minus 1 to the n is a constant, so we can write outside of the integral sign, and here 0 to 1. Now u to the 2n times natural log of u du. Okay, then how to evaluate this integral? Well, now here 0 to infinity minus 1 to the n. Now here 0 to 1. Now I'm going to use IBP, integration by parts method. So I'm going to take u as a first function, natural log of u, here d by du. Now integration of second function, u to the 2n. So we know u to the 2n plus 1 over 2n plus 1, here du. Okay, then we can write this is equal to infinite sum 0 to infinity minus 1 to the n, and here we can write now product of these two functions. So natural log of u times u to the 2n plus 1 over 2n plus 1, limit 0 to 1, then minus integral sign, here integral from 0 to 1. Now rewrite this function. So u to the 2n plus 1 over 2n plus 1, derivative of first function, so 1 over u du. Okay, then we can write this is equal to, so I minus j is equal to infinite sum 0 to infinity minus 1 to the n power, and here we know now if we plug in 1, natural log of 1 is equal to 0. If we plug in 0, this is equal to 0, so this term is going to be 0. And here we have minus sign, u to the 2n plus 1 over 2n plus 1, here u, and 1 over 2n plus 1 is a constant, so we can write outside of the integral sign 1 over 2n plus 1, and here we have integral from 0 to 1, u to the 2n plus 1 over u, then now u get cancelled, so u to the 2n du. Okay, then we can write this is equal to, now here minus sign, so minus infinite sum 0 to infinity minus 1 to the n power. Now if we integrate u to the 2n, we know u to the here 2n plus 1 times, here we know u to the 2n plus 1 over 2n plus 1, limit 0 to 1. Okay, now infinite sum 0 to infinity minus 1 to the n power 2n plus 1. Now here if we plug in 1, we know 1 over 2n plus 1, so this is 2n plus 1 square. If we plug in 0, this is equal to 0. Okay, now this is familiar with us because we know this is equal to Catalan's constant, so minus g. Okay, now we know I minus j is equal to minus g. Now this is equation number 2. Also we evaluated I plus j. I plus j is equal to minus 5 over 2 natural log of 2, and this is equation number 1. Now if we take 1 plus 2, if we take 1 plus 2, we know j get cancelled. 2 times I is equal to, so I isolated I, so I is equal to minus g over 2 minus pi over 4 natural log of 2. Okay, this is the I, and now we should evaluate at j. To evaluate j, I am going to take equation number 2 minus 1. So if we subtract 2 minus 1, now I get, sorry, I am going to take 1 minus 2. 1 minus 2, so this I get cancelled. J minus minus j, we know 2 times j, so j is equal to, we know, g over 2 minus pi over 4 natural log of 2. Okay, this is the answers. If you like this video, please subscribe this channel. Thank you for watching.